Hello everybody, welcome. In today's class we will discuss valence shell electron pair repulsion VSEPR theory. We know that due to mutual sharing of electrons, the covalent bond is formed and the covalent bonds have a particular shape and bond angles. And electronic theory of valence fails to explain these bond angles and shapes of the covalent compounds. To explain bond angles and shapes of the covalent compounds, Sidgwick and Powell introduced a new theory called VSEPRT. And in this theory, mainly we consider two types of pairs of electrons. One is bond pair electrons and the second one is lone pair electrons. So the first one is bond pair electrons and the second one is lone pair electrons. What are these bond pair electrons and lone pair electrons? Let us consider ammonia molecule. It is a covalent compound. So ammonia, we know that the formula of ammonia is NH3 and the total valency electrons in the nitrogen is 5. So 5 electrons are there in valency shell in nitrogen. Then nitrogen forms 3 covalent bonds with 3 different hydrogens. So this is first covalent bond with first hydrogen, second covalent bond and third covalent bond with third hydrogen. So from this we can conclude that these 3 are the covalent bonds and 2 electrons, total 6 electrons shared by nitrogen with 3 hydrogens. The electrons which mutually shared by nitrogen and hydrogen are called bond pair electrons. So these bond pair electrons belongs to hydrogen as well as nitrogen. And here we can observe 2 electrons are there. The 2 electrons only belongs to nitrogen. Then these electrons are said to be lone pair electrons. And nitrogen is the central atom and nitrogen has one pair of lone pair electrons. Lone pair electrons only belongs to central atom and 3 bond pair electrons around the nitrogens. Total 8 electrons. 2 lone pair electrons and 3 bond pair electrons. So this is about bond pair electrons and lone pair electrons. And this bond pair electrons repulses each other and also lone pair electrons repulses each other, also repulses bond pair and lone pair. The lone pair electrons and bond pair electrons acts like charge clouds. So due to this, always the lone pair electrons and bond pair electrons repulses each other. If we know the total number of electrons, bond pair and lone pair, then it is very easy to guess the shape. If you know exact number of lone pair electrons on central atom, it is very easy to guess the shape of the atom. And so here the lone pair electrons always try to occupy more space on the central atom because the lone pair electrons only belongs to central atom. And here the bond pair electrons also repulses each other, but when you compare the repulsion of bond pair electrons with lone pair electrons, it is less because the bond pair electrons belongs to 2 atoms, central atom as well as hydrogen. Due to this, the bond pair electrons belongs to 2 nuclei, hydrogen and nitrogen. So this bond pair electrons occupies less space on the central atom as we compare with lone pair electrons. So if we know the number of lone pair electrons on the central atom and bond pair electrons on the central atom, it is very easy to guess the shape and angle of the covalent compound. Let us consider few examples. So first let us discuss the formation of beryllium chloride. Here beryllium is called the central atom because two chlorines are attached to beryllium. Then in beryllium chloride, two bond pair electrons are present on the beryllium. We know that the in outermost or valency, beryllium has two electrons only. These two electrons combined with chlorine, we know that chlorine has 7 electron in its outermost orbit or valence orbit, and one more chlorine also has 7 electrons. So here the first electron of beryllium combined with one electron of chlorine, lone electron for chlorine, and second electron of beryllium also combined with the lone electron of one more chlorine. Then two covalent bonds are formed with two different chlorines, and this bond pair is mutually shared by beryllium and chlorine. So this is about the formation of beryllium chloride. So here beryllium is the central atom and only two bond pair electrons are present. These two bond pair electrons are present on the beryllium central atom. So the beryllium two bond pair electrons equally repulses each other and adjust to 180 degrees. Adjust 180 degrees apart from each other. So the shape of the beryllium chloride is linear. So here two bond pair electrons on beryllium equally repulses and adjust both sides of the beryllium, and which leads to 180 degrees, the bond angle 180 degrees, and it becomes, the shape becomes linear. So this is about the shape of the atom, shape of the covalent compound which has only two bond pair electrons on the central atom. Then what happens if three bond pair electrons are present on central atom? So let us discuss a example, that is boron trifluorides, formation of boron trifluoride. And boron has 3 electrons, lone electrons on it, and fluorine has 7 electrons in its outermost orbit, and 3 fluorines have only 7 electrons on their outermost orbit. 3 fluorines have 7 electrons in their outermost orbit. So here the first electron of boron combined with the lone electron of the first fluorine, and similarly second electron with the second fluorine, and third electron with the third fluorine's lone electrons. In this way the boron shares 3 pairs of electrons with 3 fluorines. So here this is the first bond, and fluorine has 6 electrons as it is. So this is the first bond pair, and second bond pair, and third bond pair, and boron is the central atom and which has 3 bond pair electrons on it. So these 3 bond pair electrons equally repulses each other, and the bond angle becomes 120 degrees, and the shape of the boron trifluoride is trigonal plane. So at the 3 edges of triangle, 3 fluorines present at 3 edges of this triangle. So this is the shape of the boron trifluorides, and the bond angle is 120 degrees. Whenever the central atom in a covalent compound has only 3 pairs of electrons, then its shape is trigonal plane, and its bond angle is, the bond angle between boron and fluorine, 2 bonds, is 120 degrees. And here we can consider that here the central atom beryllium and the central atom boron. Both have, beryllium has 4 electrons only and boron has 6 electrons, 2, 2, 2. 3 bond pair means 6 electrons. Still, to get stability, beryllium requires 4 electrons or 2 pairs of electrons, and boron requires 2 electrons or 1 pair of electrons. So this type of compounds are said to be electron deficient compound. So boron trifluoride and beryllium dichloride, both are said to be electron deficient electrons because still the beryllium and boron have no stability. So this is about shape and bond angle of boron trifluoride and beryllium chloride. Next, if 4 bond pair electrons are present on central atom, what is its shape? So for that, let us take the example, the formation of methane, CH4. We know that the valency of the carbon is 4 and the valency of hydrogen is 1 because hydrogen only has 1 electron. Hydrogen has only 1 electron in its outermost orbit. So 4 carbon has 4 electrons in its outermost shell and 4 hydrogen, 1, 2, 3, 4. So 4 electrons of carbon forms 4 covalent bonds with the electron present in 4 hydrogens. Then 4 pairs of electrons shared by carbon with 4 hydrogen. This is the first bond and second bond and third bond and fourth bond, and 4 bond pair electrons only present on the carbon. So these 4 covalent bonds equally repulses each other. So the angle will be 109 degrees 28 minutes. Here also the bond angle is 109 degrees 28 minutes. Here also, and the shape of this methane is tetrahedron. So tetrahedron, a 3-dimensional tetrahedron shape will be there for the methane. So the bond angle in the methane is 109 degrees 28 minutes and its shape is tetrahedron because only 4 bond pair electrons present on the central atom carbon. So this is about the shape of the methane. And next come to the example, another example in which it has 1 lone pair electrons and 3 bond pair electrons. Then what is its shape? For example, here let us discuss the formation of ammonia, NH3. We know that, and nitrogen will be the central atom and it has 5 electrons in its outermost orbit and its valency is 5, and 3 hydrogens have each 1 electron. Then nitrogen contributes 1 electron and shares with first hydrogen, and second electron of the nitrogen also shared with second nitrogen, and third electron of the nitrogen shared with the third hydrogen. So here nitrogen has 1 lone pair electrons. This electron pair only belongs to nitrogen, and first pair bond pair with first hydrogen, second pair with second hydrogen bond pair electron, and third bond pair with third hydrogen. And here 3 bond pair electrons and 1 lone pair electron is present on the nitrogen. Then what is its shape and what is its bond angle in the ammonia? So here, as we discussed, in the case of ammonia, 4 bond pair electrons are there on central atom carbon, and the bond angle is 109 degrees 28 minutes. Then here the bond angle of any two covalent bonds is 107 degrees 48 minutes. So the bond angle is here 107 degrees 48 minutes. So here 8 electrons are there on the central atom, but 1 lone pair and 3 bond pair electrons are there on the central atom. So then if 8 electrons are present around the nitrogen, around the central atom, that angle should be 109 degrees 28 minutes. But here why the angle, bond angle is decreased in the ammonia? It is just because of this lone pair electron. This lone pair electron only belongs to nitrogen and it try to occupies more space on the nitrogen. So it repulses its bond pair electrons. So the original angle should be 109 degrees 28 minutes. Due to presence of this lone pair electrons and occupies more space on the central atom, this bond pair electrons slightly come close to each other. Due to that angle decreases, and the shape of the ammonia is pyramidal shape. Central atom will be situated on the top of the pyramid. So here it is about the ammonia, and if 1 lone pair electrons and 3 bond pair electrons are present, then the shape of the atom is pyramidal shape. At the top of the pyramid the central atom will be present and the bond angle will be 107 degrees 45 minutes. Then come to, if 2 lone pair electrons and 2 bond pair electrons are present on the central atom, then what is the bond angle and what is the shape of that compound? Let us take the example water molecule. Let us discuss the example, that is water molecule H2O. So here the oxygen is the central atom and 2 hydrogens are attached to oxygen. So we know that oxygen has 6 electrons in its outermost orbit and 2 hydrogens have single electrons. 2 hydrogens only has 1 electron in its valence shell. So oxygen forms 1 bond pair with first hydrogen and second electron in the lone electron in the oxygen also forms 1 covalent bond with second hydrogen. Then what happens? The oxygen gets 8 electrons with 2 covalent bonds with 2 hydrogens. So this is the 8 electrons are present on the central atom. Among these 8 electrons, 2 pairs are lone pair electrons. These 2 pairs only belongs to the central atom, nothing but oxygen. And 2 bond pair electrons are there. 2 bond pair electrons are there, and these 2 bond pair electrons belongs to hydrogens as well as central atom oxygen. Then what is the shape and bond angle? As we know that, as we discussed, if 4 pairs of electrons are present on the central atom, that angle should be 109 degrees 28 minutes and that shape should be tetrahedral. But here that shape of the water molecule is V. The shape of the water molecule is V. Okay. So here why it got the shape V? And the bond angle also, it is nothing but 104 degrees 31 minutes. 104 degrees 31 minutes. Why this bond angle decreased from 109 to 104 degrees 31 minutes? Because it is very simple. So oxygen, in the water molecule, oxygen has 2 lone pair electrons. Lone pair electrons belongs to only central atom and they repulses each other and also repulses the bond pair electrons. So lone pair electrons occupies more space on the central atom. Due to this reason, the bond pair electrons repulses each other, but the repulsion of lone pair electrons is greater than bond pair electrons. So the bond pair electrons come close to each other. Due to this reason, the bond angle decreases from 109 degrees to 104 degrees. So this is about the VSEPRT theory, VSEPR theory, or valence shell electron pair repulsion theory. So if two lone pair electrons and two bond pair electrons are present on the central atom, and that shape of the atom, the central atom, then the shape of the molecule is V, and the bond angle is 104 degrees 31 minutes. So VSEPR theory could explain the shapes and its bond angle, covalent compounds, bond angle of the covalent compounds, but it fails to explain that bond strength, because it only depends on the Lewis theory. So to explain the bond strength, Linus Pauling introduced a new theory, that is nothing but valency bond theory. In next class, in next video, we will discuss about valency bond theory. Thank you.